In this video, we're continuing with measures of dispersion, measures of central tendency, and we're going to be looking at what happens with various graphs. And you're looking at the mean versus the mode. Which one, no, mean versus the median in most cases. Versus median versus mode. Which would be the best measure of central tendency? So let's think about it. If I were looking at the colors of houses on a block, and you can't really do a mean on that because they're not numbers, so you can't average them. So would a mean be a good measure of a central tendency for the colors of houses on a block? Well, of course not. You can't calculate it. How about a median? Remember, that's the middle number. You don't have a larger color and a smaller color. So the median would also not be a good thing for central tendency for the colors of houses on a block. In this case, the mode, the most common color, would give you this measure of central tendency for the houses on the block. So you see, you have to think this through a little bit. What would be the most best choice for the central tendency, the measure of central tendency? Okay, so that's one thing where it's not numbers. Okay, so let's get back into numbers. We get back into numbers, and then we can look at, say, the range of salaries in a company. Well, usually you go from your lowest pay to your highest pay. Your highest pay, which is your CEO, is probably going to have a really, really, really high salary. But you have the bulk of your workers are going to be down in the lower end salaries. So if you think about that, you have an outlier of a really high salary and maybe 2 or 3 really high salaries up at the upper end, but the majority of your workers are going to be in the lower end. So if we think about that, what would be the best measure of central tendency of our workers' salaries? Well, it will probably be the median because it's the middle score or the middle of all of the salary range. So that would be actually your best choice for the median. Whereas for the range of salaries, the median would be the best choice. The reason the mean would not be the best choice is because the mean is an average, and an outlier that's really, really high is going to pull the mean up higher, and it's going to skew that mean. The median cannot be skewed because it's the middle value no matter what of all the set of data. But the mean can be skewed according to the direction of the outlier. So if our outlier is high, then it's going to skew it in the direction of a higher value. If there's an outlier that's a low number, it's going to skew it in the direction of the lower number. So as you think about the measure of central tendency, you have to think about what influences these measures. What kind of values are there? So can we actually do a median or a mean as in the colors of houses? So you have to think about those kind of things. And so we actually have graphs that deal with this. And we're going to look at mean versus median in this case. A symmetrical graph looks something like this. And it's actually built on a histogram. If we were to draw a histogram underneath here, you would see the histogram drawing. Okay? Not very accurate, but well, let's put it here. Histogram drawing. Okay? That's pretty symmetrical. Not exactly, but if it is symmetrical, and this is a symbol that means mean, the mean is equal to the median, or fairly close, almost exactly equal. the mean and the median are almost exactly the same value in a symmetrical graph. Okay? But what if it's skewed over to the right as you look at it? Okay, there's a skew. This is skewed to the, actually it's skewed to the left. It's the tail. This is left skewed, and I always get them mixed up because I want to look at the big quantity as a skewing, but it's the little quantity. It's skewed to the left here because the smaller value is the one that's pulling it away, okay? So in this case, your mean is going to be less than the median, and it will be left skewed. The last one is going to have a little tail running off here to the right. And this one is right skewed. And in the case of a right skewed graph, or a right skewed set of data, the mean is going to be greater than the median. In other words, if we were to put the median in, the median would be somewhere maybe here, and the mean would be here. Whereas on this one, the mean is going to be here, and the median is going to be here. Okay? It changes the position of where they are. Okay, so we've looked at those. Now our next step is to look at how this all interrelates. And one thing we haven't talked about yet is that measure of dispersion called the standard deviation. And the standard deviation, we will learn to calculate it, but not today. The standard deviation is how far from the mean is the data set. So we will look at that next. And because a standard deviation is a measure of distance, a standard deviation cannot be a negative number. So if you get a negative standard deviation, then that's not possible. A standard deviation is actually an average of the distances from the mean. And that's actually what it is. It's an average of the distances from the mean. So if we were to have a set of data, the mean would be expressed in a horizontal line. The distances are these. This is what your standard deviation is. It's the average of the length of those distances from the mean. And except for error of rounding, if you added all these distances up, you would have a 0. So we can't just do a standard way of doing an average with these distances, and that's why it's such a long, involved process to figure out the standard deviation. And as I say, we're not going to do that today. Instead, what we're going to do is we're going to look at how this affects certain things. Let's see, are we going all the way there? Let me check. Yes. We're going to look at what is called the empirical rule. And the empirical rule is a rule that says when you are so far from the mean, then so much of the data points lie within that amount. So if we were to draw our normal curve, that's what this is called, the normal curve. When you put the normal curve up, your mean is right in the middle of the curve. And there are other ways we write that mean as well. Let me show you that symbol so you'll know what it is when you see it. Okay. It's not introduced in this assignment, so we won't worry about it at this point. But that mean is the middle. Now, one standard deviation on each side of that mean, this is one to the left and one to the right, this contains 68% of all the data lies in there. And then we have here another standard deviation on each side. Let's make it a little bigger so they're even. This one contains 95% of all the data. And then down here, this one contains 99.7% of all the data. And that leaves just 0.3% of the data to reside in those little tails, which if you divide it by 2, this is 0.15% is in there, and 0.15% is in this one. Now there are some differences with what happens with this. If we were to look at the empirical rule and think about what it means, well, it gives you a placement in relationship to other people. When we do a test and you get a 90% on your test, what that means is that you got 90% of the problems of the test correct. But when I tell you that you are the 90th percentile, which is what this one is, 90th percentile, this means that you are the 90th, did better than 90% of the people who took the test. So there's a difference in the meaning of it. Okay? So percentile deals with exactly where you are in relationship to everyone that took the test, whereas 90% is the exact grade that you got on the test in relationship of what you got correct to the total number of problems possible. Okay, we will stop there for now, and that will be it for that video.